Hi everyone, this is Miguel Alfonso Mendez from the von Karman Institute for Fluid Dynamics, and I welcome you to the release of our open source package SPICY. This is a software which we've been developing at the von Karman Institute, in short the VKI, for meshless pressure integration and data assimilation in image veloCimetrY. In this and in the next videos, I will tell you more about this code, its architecture and its theoretical background for its methods, and we will go through various exercises and tutorials. The goal of this channel is to offer a mini course where you will find everything you need to use the code wisely. But first, let me present you the team. This work started as the master thesis project of Pietro Sperotto, who came to the VKI from Politecnico di Torino. He stayed with us for his research master program and now moved to Dantec Dynamics, where he works as a software developer. Pietro did most of the heavy lifting and developed the first version of the code, which I will be presenting. Now, most of the developments are carried out by Manuel Ratz, who came to the von Karman Institute from TU Ilmenau for his bachelor thesis, and he has been working on SPICY during his research master program here at the VKI. Manuel has been developing several improvements which will be presented in a dedicated publication very soon. And last but not least, we have with us Professor Sandra Pieraccini from Politecnico di Torino, who has been co-supervising Pietro during his master thesis. She is an expert in numerical methods and gave us a lot of good advice on the numerics. The main idea behind SPICY is presented in this paper, which was published last year and is also available on arXiv. Briefly, the goal is to start from scattered and maybe noisy velocity fields and then obtain an analytic expression for both the velocity and the pressure fields. When I say analytic, I mean that we can compute derivatives without resorting to numerical approximations such as finite differences, and most importantly, without even the need of a grid. At the moment, we only consider incompressible flows, so solenoidal fields, and pressure computed for laminar conditions. In this paper, we focus on synthetic cases for which we had the ground truth, and so we could compare the accuracy of our solver. And we consider both 2D and 3D problems. Now we are about to present results on an experimental data collected at VKI and also consider turbulent conditions. The main engine behind SPICY are physics-constrained radial basis functions, in short RBF, as we will see in this mini course. We divided the course into 10 videos, 5 covering the theoretical background and 5 dedicated to tutorial exercises. Then we will close with an overview on ongoing works and perspectives, and this will be given by Manuel Ratz. Within the first 5 videos, we will introduce the notion of RBF approximation and how to use them for regression and for solving partial differential equations, PDEs. Then we will go into the details of penalties and constraints, the regression of velocity fields and pressure computation, and finally the numerical methods implemented in the code. In the second part, we will first provide an overview of the SPICY class in Python and then present 4 tutorials. We will start by solving PDEs in 2D, then move to penalized velocity regression, constrained regression with pressure computation, and finally a test case in 3D. I hope that you enjoy this mini course, and I look forward to meeting you in the next videos.